Let's find the best time to buy and sell stock. So we're given an array of prices where prices at index I is the price of a given stock on the ith day. We want to maximize our profit by choosing one day to buy a stock and one day to sell the stock. As an example, we have an array of prices, and these are the prices on different days. So we can see that on the 0th day, the price is 7. On the first day, the price is 1, and so on. And just by looking at this, you would probably be able to tell that the best time to buy is on day 1 and the best time to sell is on day 6 because it gives you a profit of 5. In example 2, we see that the price of the stock keeps decreasing, so there's really no profit that you can get from buying on any of these days. These are the companies that ask this question, a pretty popular one. Going into the intuition of it, it might be easy to come up with a brute force solution where you just look at all possible pairs of numbers for each price on each day. So comparing 7 to 1, 7 to 5, 7 to 3, 7 to 6, 7 to 4, and then moving on to 1 and doing that. And that ends up with an O of n squared complexity, which if you want a job, then we're going to do something more clever here. Now, I think this is more of a logic puzzle really than a coding puzzle. What we'll do is we'll find out the maximum profit in only one pass of this array. And you might be wondering how we're going to do that. The first thing we want to do is we want to keep track of the lowest price when we iterate through the array. So we start the lowest price at some really high number. And on the first pass, we set it to 7. Second pass, we set it to 1. Third pass, we don't set it to 5 because 5 is greater than 1, and then so on and so forth. Meanwhile, we want to have a max profit variable that will keep track of the maximum profit we've seen so far. So we can just do that by subtracting the current index from the minimum price. And you can test this on a bunch of cases yourself, but I'll tell you that this algorithm always works no matter what. So to demonstrate another example, as we iterate through the array, our minimum will first become 7, and we compare it to 7, the profit is 0. Our minimum then becomes 1, we compare it to 1, the profit is 0. We compare 1 to 5, the profit is 4. We compare 1 to 0, we found a new minimum, so we switch the minimum to 0. And then we compare 0 to 10,000, so our max profit will end up being 10,000, which is correct. And just as an example, if I had 0 here instead, you can see that the profit calculated from the new minimum is going to be 0. But that doesn't matter because we've already stored the max profit we've seen so far, which is 4. So like I said, you can test this method on a bunch of other cases. It might also help to graph it out yourself, and you'll quickly see that this is the solution for all cases. In the code, we're going to make a min price variable, and we are going to set it to infinity. So it's going to be float inf. That's how you make a really, really large number. We'll also set the max profit to 0 and then start iterating through prices. First, we'll check if the current price is less than min price. And if so, we can set min price to price. Next, we'll check if price minus min price is greater than max profit. And if it is, then we'll just update max profit. In the end, we can return max profit. So that's the optimal solution. You'll get a job with this solution, and it's all O of 1 time since we're only keeping track of 2 variables.